This is Neil Schneider for MTBS-TV at CES 2013. I'm at the Oculus Rift private suite, and this is actually pretty cool, but we don't have to get into that right now. And what I'm holding is the Oculus Rift prototype SDK, and to my immediate right is none other than Palmer Luckey. Welcome to the program, Palmer.
Thank you. Great to be here.
Now, Palmer, first, may I say this is like pretty much the first time we've met face-to-face. I mean, we've known each other for a while now, but it's really, really awesome that we're meeting in these circumstances. Honestly, I don't think anyone could have expected this, and it's really a positive turnout. So I congratulate you, first and foremost, on everything you've accomplished in such a short time. So why don't we talk a little bit about the Rift? I mean, let's start with how it started as an idea, and let's move on from there. Like, what sounds like you were kind of frustrated before, and that kind of motivated this. Tell us the story.
So the short version of that is, I had bought a bunch of virtual reality headsets. I had been a Stereo 3D enthusiast, and there was nothing that was the headset that I actually wanted to buy. There was nothing that was something that I wanted to use for gaming or that I could use for gaming. And so being a bit of a hacker and hardware enthusiast, I said, well, I guess I'm going to have to try having my own go at this. And I didn't really expect that I'd be able to come up with something, amazing or anything, but I figured I could do better than what was on the market.
Okay, so we don't have to name names, but what would you describe as being the biggest problems with, head-mounted displays, or we'll call them VR gizmos, if you will, on the market? Like, what was out there that wasn't meeting your needs?
So the main problem with most of the VR gizmos is that they weren't very good at being VR gizmos. They were maybe optimized more for being personal video viewers, or something that kind of sort of worked with games using mouse emulation, but there was very little in the way of something that you could call a VR headset until you got into the professional space or the military space. And the problem with those was mainly cost. We're talking tens of thousands of dollars.
Now, how would you, for people who aren't familiar, like you just said, like a mouse interface, could you just elaborate a little bit as to what you meant?
So normally a first-person shooter, you're controlling using a mouse, which is a relative input device, not an absolute input device. There are several VR headsets on the market, and they basically use a gyro and accelerometer, or just accelerometer, maybe paired with other sensors. And even if those are really good sensors, all they're doing generally is emulating a mouse. So you turn your head, and it also emulates input of a mouse turning left. And that works sort of, except it's generally higher latency, it's not very precise, and it's a relative input device. It's not absolute, so you're going to end up with some manner of drift over time, especially if a game has some kind of mouse smoothing or acceleration algorithm.
Now, I know this sounds like a silly question. Everyone says latency, 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 but maybe you could talk about exactly what that latency is, why it's so important.
So latency in our case is basically like the motion to photon time. How long does it take between when your head moves and when the pixels on the screen start changing in response to that input?
And I take it that's important for gamers?
It's absolutely critical for gamers. I mean, not just in the Rift either. In general, you want to be running at a high frame rate. You want to have really low latency so that the inputs you make to the game, whether they be by your head or your gamepad, actually occur in game as quickly as possible. If you have a bunch of latency, then your actions are occurring later than you wanted them to, and you're going to end up performing at a lower level and also having an inferior experience. Okay,
excellent. Now, so here we are. You're a little frustrated because the existing head-mounted displays aren't what you want them to be. So what was your next step?
Next step was just to buy as many head-mounted displays as I could, and I took them apart, reverse engineered quite a few of them, and I started to learn from a lot of the mistakes maybe that they made, or the limits of the technology in these head-mounted displays. And so I started to work and made various different prototypes and refined them slowly over time. And I ended up with a prototype that I thought was pretty good, and so I had been posting about my progress on actually the MTBS-3D forums. Got a lot of good attention there, and John Carmack actually ended up on those forums posting a bit, and so he contacted me and said, "Hey Palmer, one of your head mounts, it really looks like something that I'm interested in. Could I buy one off you?" And I said, "No, you're John Carmack. Of course I will just lend you one for free," because that's what you do when it's John Carmack.
Now, as when you were building this prototype, I mean, there must have been certain criteria you were trying to accomplish. What were you trying to do with the prototype that was far different from everything that was available on the market?
mainly field of view. I was trying to make something that had a very wide, very large field of view that covered as much of your visual field of view as you could. You want the image to be large. You don't want to feel like you're looking through toilet paper tubes at a few little squares at the end. You want to actually feel like you're in the space. That was the main thing that I was working on, because that's where all of the other head-mounted displays really fell short.
Okay, so maybe if you could just elaborate. I know this may seem like a silly question for experienced gamers, but for people in industry who may not be following this, can you elaborate a little bit more about what field of view is from the point of view of technology like this?
So you have a physical field of view, and then there's also a virtual field of view. The virtual field of view is basically how wide is the angle of the virtual in-game camera, how wide is the angle that it's rendering. Is it doing a very narrow view, almost like a zoomed-in view, or is it rendering a very wide view? On the physical side, you have a field of view as well. So if you have a small monitor, it's taking up 20 degrees of your field of view. A large monitor might be 60 degrees of your field of view. And with our head-mounted display, you get approximately 90-degree horizontal field of view. So it's a very large image. And by rendering a virtual image that is very wide and matching it onto a physical field of view that is also very wide, you end up with a really realistic experience.
So with earlier head-mounted displays, I take it FOV or field of view was a big challenge. Did it cut out the realism by not having enough of a field of view?
I wouldn't even say it cut the realism. It just never got anywhere near realism that you could cut, because it was, a lot of these head mounts, they were optimized for movie viewing. They weren't necessarily optimized to be a wide field of view immersive VR experience. So a typical consumer head mount had a horizontal field of view maybe in the 30-degree field of view range. There were a few that came out, like the Sony HMZ T1, that really pushed that, and it had a 45-degree horizontal field of view. But I mean, that's still not nearly enough to have a great virtual reality experience.
I mean, in this case, you're doubling that. Am I correct?
It's actually more than that. You're not just doubling. It's like if you had a monitor and you said, well, this is a 15-inch monitor and this is a 30-inch monitor. The 30-inch monitor is not twice as big. It's actually 4 times as large because, it's wider and it's also taller. In our case, the image is actually wider or taller than it is wide, so you end up with an image size that is between 6 and 10 times as large as most of the consumer head-mounted displays on the market.
Okay, excellent. Okay, so back to our story.
Yes.
So you sent this, or not this one, but you sent a head-mounted display to John Carmack, and then what happened?
He ended up showing it off at E3 running Doom 3 BFG Edition, and that got an enormous amount of attention, a lot more than I would have gotten just putt-putting around on my own. It's a really great piece of software, and John Carmack has a lot of respect in the industry. So I started talking to quite a few people who were interested in, I was planning on launching my own Kickstarter, and it was going to be a do-it-yourself, build-it-yourself kit. And so I started talking to a few people about the potential of commercializing it and or making something that was maybe a little more accessible to your average programmer than something that you actually had to hot glue together yourself with quite some precision. So I ended up hooking up with Brendan Arib, who is one of the co-founders of Scaleform, and then later was one of the executives at Gaikai. And when Gaikai sold to Sony, he came right over to Oculus and he helped me really make a good go at this. And we made a great Kickstarter video. We launched that. It was pretty incredible. We had a $250,000 goal. We ended up raising $2.5 million over the month. We broke our $250,000 goal in about 3 hours. And so we use that money to build developer. We're using that money to build developer kits for the people who ordered on Kickstarter. Basically, an early version of the head-mounted display that's fully functional, and it's an actual manufactured plastic shell device, and they can use that to develop games and to give us feedback on what the consumer version should eventually be like.
Excellent, excellent. Well, we should give this a go. So they're just going to get this on my head, and then we'll continue.
All right, let's do this.
Okay. All right, thanks, Palmer, for putting the device on my head.
Of course.
All right, first off, what am I looking at here?
So what we're looking at here is Epic Citadel. It's basically a tech demo that was used in the iOS Infinity Blade. You can't actually do anything right now. You can just walk around and look at stuff in this particular demo.
Okay, so for the experience I'm having here, well, first off, this is really neat. Like I'm looking through the head-mounted display, and it's not like looking at a screen. I've tried other solutions in the market, and usually you really do see the screens in front. It's as though you're kind of in a movie theater in the back of the audience, and you're just you're watching what's in front of your eyes. But in this case, and I see that I have head tracking, which, for those who aren't familiar, it really means that the display is reacting to what my head is doing. So it's now, Palmer, if I can ask, it wasn't just enough to do this field of view. I understand that you're developing some innovations around head tracking. Can you elaborate a little more about that?
So the early prototypes that we're using an off-the-shelf tracker. And it was running at 250 hertz and used a gyroscope and an accelerometer. We ended up developing our own sensor board that runs at 1,000 hertz, 4 times the speed that we were running at before, and uses an accelerometer, a gyroscope, and a magnetometer, which is essentially a digital compass, so that you can compensate for drift on the yaw axis. It's one of the best trackers, I think, out on the market, and almost certainly the best tracker out there for VR. Another thing that we're working on is head modeling. So your head isn't just rotating in space or rotating around a central point like it would with a mouse. When you move your head in real life, it's able to move around, within the confines of your skeleton, within the confines of how your neck can move. And so we're working on models that emulate how people's necks actually move, so that when you move in game, it's moving in a very realistic fashion. Another thing that we are working on is predictive head tracking. So latency, while pretty low on our system, is still a little bit of an issue. So one thing that you can do to mitigate it a bit is when you start to move, even at low velocity, we can look at that motion and predict where you're going to be at the end of the next frame. So what we can do is render that frame ahead of time, so that by the time it gets pushed to you and it's on the screen, you're already there.
This really is something else. And I notice, even as I bob my head to talk to you, the screen is moving in tandem. Now, you mentioned that this is obviously, actually it's a work in progress, that you're going to have this 1,000 hertz head tracking. Just so we could put this in perspective, what would be a standard head tracker as far as responsiveness compared to what you're doing?
So a typical rate for a head tracker, it's hard to say, there's not that much VR hardware on the market, but a typical rate would be somewhere between 60 hertz and 125 hertz. You certainly see trackers going up to 250 hertz, 360 hertz, maybe 500 hertz, but as far as I'm aware, 1,000 hertz is unparalleled, at least in the consumer market.
Okay, excellent. And now this prototype, is it using the higher speed head tracking, or is it using something else?
Yes, this prototype is using our newest tracker.
Okay. Now, I imagine with really fast head tracking, there must be aspects about the screen that have to be compensated for as well. How is it for the screen to refresh fast enough? Did you have to make any special enhancements for that purpose?
The screen and actually in the prototype you're trying, it's one of our older prototypes. The ones that we're shipping have about half of the switching time of this panel, so they're much, much faster. Of course, you're not going to get a panel that's able to switch at 1,000 hertz, so the screen is definitely a limiting factor here, not necessarily the sensor. We've designed our own video control board for the LCD display as well, which is designed to have minimal latency. It doesn't do any kind of video processing. It just pushes the pixels directly to the display.
So just for those who aren't familiar, so when we're talking about the response time, maybe you could elaborate as to what the side effects are if the screen isn't refreshing fast enough. Why is that important?
So if the screen isn't switching states fast enough, then what you end up with is quite a bit of motion blur, quite a bit of smearing, and you also have increased latency. It takes longer for the image to respond to the inputs that you're making, so they appear to happen later in time rather than right along with your own movements.
Excellent. It kind of, when it comes to immersive technologies, I don't know, this isn't as much a question as it is a statement. When they were talking about 3D, everyone was complaining about the glasses. But, granted, this is a light device. It's comfortable to wear. But I'm really not bothered at all by putting something on my head because it's actually delivering a very immersive experience. I'll say the same 3D does as well. But this is really just, it just demonstrates that headwear is not a deterrent if you're getting a positive visual experience that adds immersiveness to your entertainment. Have you had a similar response from other people?
Well, I mean, it's a bit of an obvious response, too, because a lot of people, they see these 3D TVs and they see you wearing the so-called dorky glasses and they say, oh, well, you know, come back to me when there's no glasses and maybe I'll use it. But it's pretty clear that nobody's going to use this thing and say, well, I don't know, come back to me when you don't have to put something on, because that's, you know, clearly not going to happen. So I don't think it's a deterrent when you're giving a significantly improved experience over a traditional monitor.
Now, let's talk about, I mean, I know that the head-mounted display in this case, or the Rift, I mean, a lot of it is visuals. Obviously, a very important component of this with the head tracking is interface, because, you know, you're looking around. I mean, that's a form of interface right there. I'm using a joystick right now, but do you think there's going to be a paradigm shift between, you know, once gamers are using technologies like this, you know, on a regular basis, what kind of paradigm shift, if any, will happen around interfaces, how people interact with their gaming content?
You know, I'm not really probably the best person to make guesses at that. I'm not a developer, but that's why we're getting these developer kits out there so people can experiment with new interface devices. I mean, we're using a gamepad for our demos because it's a tested, tried and true interface that's very easy for people to pick up and understand instantly, which is important when you're doing tons and tons of demos. But I think that there's some really cool motion-based interfaces that are going to come out targeting VR, and even we're looking at those possibilities in terms of hardware and software and what the best way to control a VR experience is.
Well, let me ask a question a different way. You know, I'm using this display. I moved my head around, and you know, obviously the response is good, and I know it's going to get even better with the enhancements coming down the pipe. Do you think that this head-mounted display is going to require a new way of thinking when it comes to game development? And let me elaborate a little bit more. Normally, when I'm aiming in a game, let's say I'm playing Battlefield 3 or Call of Duty, and I'm using my mouse, and it's pretty accurate. It's got to be actually accurate if I'm going to score well. When you're dealing with a head-mounted display like this, where head tracking is part of the component of how we're looking around and aiming, in your opinion, will that continue to be effective? Do we need to start exploring new ideas?
Yes, absolutely. I don't think that tying the aiming to the head is necessarily the best control scheme. I mean, it's very interesting, and it's actually very cool because you can draw a really fine bead with your head a lot better than you can with an analog stick. Maybe not as good as you can with a mouse. I mean, a mouse is a superhuman interface. You can rotate faster than you could possibly imagine doing in real life, and then stop with perfect precision. But I think that we're very much going to see different control schemes, because that's really what it is. It's a matter of control schemes. A very simple step would be to just decouple the head look from, you know, your body movement, and that's something that we've done internally and are experimenting with in demos. You could also tie your movement to other motion devices and then have the headset be its own input device. But we're not trying to solve that problem on our own because we don't think that we'd be able to necessarily best solve it. It's better to have a lot of minds working on this all at once. And, you know, again, it comes back to that's why we're putting out these developer kits. People can mess around with this. They can try all sorts of different control schemes, and we can learn from that as we move forward.
Well, you know, and again, I think in a way it's a good thing, because when you invent something new or you create something new and there's a problem to be solved, it is good when other people start solving problems that you create. It's helpful when there's
yes it is.
You know, and by the way, for, you know, I don't know if I could convey the screens in the background. Normally, you know, in a game when you're playing, it's unusual to be able to look over. Usually you walk straight, backward, left, right, maybe you rotate.
Yeah.
But check out this experience, and I'll go to the fruit table here. Here we go. Now, it's not as delicious as what you'd find in my home, but I could literally look down at the tomatoes and the green beans and the yams and
fruit's really right in your face.
Yeah, but do you have anything unhealthy on the menu? Is this all you have to offer?
That's all I have.
No
right
chocolate.
Now. Sorry.
See, maybe in version 2.0 they'll have cake and muffins and stuff. But this is really, really cool. So here's a question for you. Now, this is obviously, you know, I saw the keynote presentation with Micah Brash and John Carmack and at QuakeCon and yourself, of course. And Mike made a remark that he goes, well, you know, 3D is not all that important. It's not, you know, because it's actually the visual cues. But I got to tell you, I mean, the 3D on this is really impressive. I mean, you see really deep into the scene. The snowflakes are coming down. Now, when dealing with stereoscopic 3D, usually you have a screen right in front of you, and then you could control whether it's all depth or you have things coming out of the scene, or you could make a balance between the two. Do you deal with the same type of flexibility when dealing with a head-mounted display? Is it handled very differently once the screens are right in front of your eyes?
No, it's actually handled in a very similar fashion. I mean, you're still putting objects at different places in space. The difference is that you want to put them where they actually are in space, not in some abstract, compressed, pseudo 3D monitor type experience. And when you have in-screen, at-screen, and out-of-screen effects, what you're really doing with the Rift is the exact same thing. The only difference is that you don't have the edge of a screen to use as a reference point.
Okay. And now this is, I gather, this is like a native 3D rendering, which means there's an actual left and right camera view. Why don't we talk a little bit about the software support? I mean, remind me, this looks like, I think it's like an Unreal.
Yeah, this is Unreal 3.
Okay. So what kind of software support can we expect down the pipe?
So you're looking right now at our Unreal Engine 3 demo, which we have working really solid. We also have a Unity demo and integration that's working really well. We also have a room that we've made in our own little engine in C++, and it's just basically an empty room with just a few things in it. And that's just a bare bones example, and we're providing all the example code for that so people can integrate it into other engines and games as well if they want to do that on their own. We've got a really nice set of software support, and when we deliver this to developers, it's going to be very easy for them to get working immediately.
One of the big advantages that stereoscopic 3D had was you were able to use 3D drivers. Like the game would be in DirectX or OpenGL, and you could extrapolate a left and right camera view. Now, in this case, what I see that's really different is that you could look over things. You know, like you could look into a bin of fruit. And I don't think you could, you know, a driver would necessarily do that because it's the game that has to be programmed to allow you that flexibility. But do you think that 3D drivers could have a future in technologies like this?
Maybe in the distant future. The main problem with a driver isn't generating the appropriate imagery. Sure, you can, you know, use an injection-based driver, and you can do some really cool stuff. You could probably get it displaying pretty well. But unless they have absolute tracking input, you're not going to be able to provide it really good head tracking. And also, games aren't designed with VR in mind, so they're going to have all kinds of camera shaking effects or head bob or taking control of the camera for cinematic sequences. And those are things that are not going to be handled well by a 3D driver. And you might be able to ignore them in a stereo 3D monitor, but they're the kind of thing that you're not going to be able to ignore in a VR headset. And latency is another concern. You really need to try to minimize the amount of latency in your game between the input and when your head turns. And I don't know if you've ever played any games, but there's some games, especially ones with mouse smoothing, that have quite a bit of input lag that you can perceive even with a mouse. If you were to put it on your head and then try to use mouse emulation as a head tracking input, it's going to work in an abysmal fashion.
Okay. So now that people have had the patience of listening to me ask you all these questions, when can we expect, or when can we look forward to, first off, the SDKs hitting the market?
So the developer kits are shipping in about a month and a half. We're going to be shipping them in March, and we'll have them all shipped pretty quickly, mostly at once. Then we're going to wait for developer feedback. We're going to let people try them and say, this is what you need to do for the future version. This is what we think is really important. And at the same time, we're going to continue to develop prototypes in our lab. And we already have some early prototypes of the consumer version that we've put together. And we can't wait to use the combination of our work and developer input so that we can put out a fantastic consumer version as soon as possible.
Now, from what I'm gathering so far, it's starting off very much as a PC-based technology. Do you envision this going mobile, or I mean, what do you see as the horsepower that would drive this machine in the future?
Our SDK already supports Android as well as PC because they're both open platforms. It's very, open in the sense that anyone can very easily create a peripheral for an Android or PC device, and they can also easily write software for either of those. Working on a console, there's no technical reason that you couldn't work. This is all pretty standard input and output that you could make work. It's just a little bit of a longer road to becoming a licensed peripheral on a console and getting consoles that have enough power to run something at 60 frames per second in stereo 3D with low latency. But definitely, there's no reason that this couldn't work on consoles, and we're actively investigating that right now.
Excellent. Now, I know this is a little bit of a sneaky question, but I noticed that on your staff, I mean, your CEO is Brendan, I hope I'm pronouncing it, Irib, yes, and formerly from Gaikai, who was in the cloud gaming business. Is cloud gaming very important for this?
No. I mean, it could at some point in the future become really cool, and maybe that's something that we'll investigate with the consumer version. But at least for right now, for this developer kit, streaming isn't something that is matured enough to really. It's really not possible to imagine it working well with 3D. A good latency figure for a stream is somewhere in the 40 to 30 milliseconds range, and we're trying to get under that just for our own motion to photons loop. You can't double that and have a good VR experience. So maybe streaming will have some use, but as it stands today, it's not possible to have input on this end, stream to a server, render a frame, and send it back with anything close to enough speed for good virtual reality.
Okay, excellent. I'm going to take the goggles off now.
All right.
Is it just pulled them back? Here we go.
There you go.
Wow. Oh. Yeah, this isn't the same at all. Anyway, so thank you so much. This is really, really awesome. I think this is going to be a very big success. I think the game developers should grab hold of this as soon as possible. And I take it, so for PC, it's not hardware specific. I take it it will work on all graphics cards?
It'll work on any graphics card. Well, wait a sec. It'll work on any graphics card, but there are certain integrated graphics chipsets that you shouldn't really expect to have any kind of real VR experience on. Not because it's not compatible with them, it's just a matter of rendering power. There are certain chipsets that are not going to be able to render well enough. But yes, it will technically work with any graphics chipset, and there's no particular graphics chipset that it works so much better on than another.
Okay, excellent. Well, I'm really looking forward to getting my own, and I am going to be counting the days until this gets shipped, and I think I'll be playing Doom 3 BFG a few times over. And again, thanks so much for joining us, Palmer.
Absolutely, it was a pleasure, Neil.
And of course, we'll still see you on the MTBS forums, yes?
I'm on every day.
Okay, excellent. Well, thanks for watching. This is Neil Schneider for MTBS-TV at CES 2013.